On the 14th of October 1947, Captain Charles "Chuck" Yeager of the United States Air Force climbed aboard his Bell X-1 aircraft slung beneath the B-29's Super Fortress. Following his release, he leveled off at 40,000 feet above the Mojave Desert and fired the third of the aircraft's 4 rockets. Initially, the ride was rough and control almost non-existent. Then, as he neared the speed of sound, Mach 1, the ride smoothed out and control was regained. Quickly, the needle went to 1.02, paused several seconds, and then jumped to 1.06. And that was it. Chuck Yeager had earned his place in history as the first man to pierce the dreaded sound barrier. Although news of the achievement was largely ignored, even suppressed, it only served to show just how much ground the British had lost in the quest for supersonic flight. But it put in train the events that would result in Britain's first supersonic fighter, the Lightning. By 1942, there had been a number of incidents of pilots failing to pull out of dives whilst locked in combat. Some pilots did regain control and reported that the aircraft's controls had become solid whilst diving, accompanied by a severe buffeting. Initially, these reports had been dismissed as understandable confusion in the heat of battle. But as more powerful engines became available, the reports began to multiply.
At around about the end of 42, when I joined Hawkers, the Hawker Company, Chief Test Pilot George Bullman, and his supporters Ken Smith and Bill Humble, had started to investigate a phenomenon which was occurring on these big new fighters. This was loss of control and a very considerable buffeting and roughness that was experienced where they were diving these airplanes high up. It wasn't happening low down, but if they tried to get these airplanes to dive to their limiting speeds at high altitude, they were running into control difficulties.
Aerodynamics specialists working at the Royal Aircraft Establishment at Farnborough had come to believe that the cause of this phenomenon was a change in flow characteristics over the aircraft's surfaces due to the air becoming compressed as it approached the speed of sound. Quite simply, in the thin air at high altitude, the aerodynamics of the aircraft were preventing it from going any faster. As the aircraft reached the thicker air at around 10,000 feet, the pilots were able to regain control. By 1942, the terms supersonic and compressibility were beginning to be used in discussions about these incidents. A new and apparently impenetrable limit had been reached, and fighters were now dived to their compressibility limit as part of their test program.
We at Hawkers were investigating why, and we did find during that period, and had established by about mid-1943, that if you got into this frightening lack of control, right into the point where you were actually out of control, it was rolling and diving away from you, despite everything you could do with it. If you stayed there and rode it down from 15,000 feet or so down to about 10,000 feet, the speed of the aircraft relative to the speed of sound as you got into the thicker air reduced. And as that occurred, the shock waves died down and control came back. And so this was known as compressibility. It was a recognized condition by the end of 43, and the designers were very, very busy trying to design the next generation of airplanes which would overcome this problem. But until they did, and it really wasn't until after the war that we got airplanes that would actually cope and get right through this condition, compressibility was a limitation which all the air forces had to observe, and pilots had to be trained to avoid getting into it.
Raising the point of compressibility was only one part of the problem. The other was designing an engine powerful enough to fly even faster. Piston engines had virtually reached the limits of their potential, and so in 1942, British officials began to take a new interest in a concept dismissed by them some years earlier: Frank Whittle's jet engine. Meanwhile, Germany had also been developing a jet. However, by the last year of the war, the Luftwaffe had been beaten back to a point where its only useful role was one of air defense against the Allied bomber formations that pounded German cities by night and day. In this defensive capacity, they were helped greatly by the arrival of the Messerschmitt 262. Its rate of climb meant that it could be scrambled in time to intercept Allied bomber formations. But what came as a shock to the pilots flying fighters like the Mustang and late Mark Spitfires escorting the bombers was the sheer speed of the Me-262. Not only was it nearly 100 miles an hour faster, it could dive significantly faster. The swept wings and jet power of the Me-262 showed that military aviation had reached a new threshold.
With relevance to the swept wing was the very high Mach number that could be achieved with it in control, as opposed to any of the Allied aircraft flying at that time. I mean, it was a huge gap, a quantum jump, really.
The Germans set about their research in a way which was very effective, and by the middle of the war they were advanced very considerably in terms of aerodynamics and high speed, and they had produced a number of experimental aircraft which would get very, very close to the speed of sound. The first one that was of practical value was the Messerschmitt 262, which was a twin-engine fighter. That in 1943 was streets ahead of anything that the Allies had. It was being built and developed at the time as our Meteor, but it was a better aerodynamic concept, and it was so far advanced that the Germans were able to put it into service in 1944.
At the same time, Gloucester was beginning flight trials of its E-28 prototype, which was powered by Frank Whittle's jet engine. Although the specifications had been for a research machine, it was planned to develop the aircraft into an interceptor fighter with fixed guns. The result was the Gloucester Meteor. Although it was only used in defensive operations against V-1 flying bombs, the second most powerful air force in the West had entered the jet age.
The Meteor 1, 2 and 3 were inadequate, underpowered and not effective fighter aeroplanes. The Meteor 4, with the Derwent 5 engines considerably uprated, slightly improved aerodynamics, was a better and more capable aeroplane and provided a basis for training the fighter squadrons of the Royal Air Force in the use of jet fighters. Having said that, it was never an air superiority fighter to match aeroplanes like the North American Sabre or the MiG-15, but it was, for the late 1940s, it was a good step forward. It was a reliable aeroplane, and it trained the Air Force to fly formation in jets and do high-speed intercepts and so on.
There was, however, more to the beginning of the jet era than the introduction of this new and greatly increased source of power. Compressibility remained a problem, even with jet power. The challenge was now to produce designs that were aerodynamically capable of controllable flight at even higher speeds. And so the period immediately following the Second World War was one of change and excitement in aviation. The Allies lost no time in scrutinizing German research data on transonic aerodynamics. But the race to go supersonic was all but over, even before Chuck Yeager began his historic mission. The British government had cancelled the Miles M52, a research project begun in 1942, but now in its final build phase. The aim had been to design an aircraft capable of going supersonic. It had a number of design features that made it look remarkably like the Bell X-1, but there were misgivings about its potential in high places. The official reason was that the cost was too high, and besides, flying through the sound barrier would be too dangerous for the pilot.
When the news came, I was absolutely shattered. And I think we were sitting in the jet flight when we got a notice from the director telling us that the project had been cancelled. And it was as if we'd all lost a best friend. Really, I can only say we were totally crestfallen at the time. And at first, that was how it was. Then it began to boil up a little into anger that this had been done without consulting us. We felt, as the test pilots, we should have had a say in the matter. But maybe that's asking too much.
A supersonic aeroplane had to come, and then the government, for its own reasons, cancelled. So there was an enormous sense of, well, we're losing the place. You know, we were about to lead the world, and now we're being restricted and held back. And then, of course, the following 6 months, then the Americans did it. And, of course, they headed leaps and bounds. And we, in fact, lost about 10 years in the development of military fighter aeroplanes as a result of that decision.
Meanwhile, the RAF soldiered on with its Meteors and de Havilland Vampires, which had come into operational service in 1946. Despite its outdated design, the Meteor went on to set the world speed record in 1946 of 606 miles per hour. However, it was becoming clear that the West faced a new threat to peace from Soviet Russia and her satellites in Eastern Europe. Russia had been massively hurt by the war, and its leaders and people never wanted to have such pain inflicted on it again. For this reason, she began a program of rapid modernization of her armed forces. In particular, the Air Force benefited greatly from help given to her by her former allies. B-29 bombers, formerly belonging to the US Air Force, provided the basis for a new long-range bomber force. Then Britain provided the Soviets with a batch of Rolls-Royce jet engines. Soon, the Russians had a transonic jet fighter of their own, the MiG-15. Soviet intentions became even clearer when in December 1947 they mounted a blockade of Berlin. The Iron Curtain had come down across Europe. The Cold War had begun. To compound their problems, the RAF were horrified when Australian Air Force Meteors were shot out of the skies by MiG-15s during the Korean War. However, in Britain, the Chiefs of Staff had already begun to respond to the threat. An order for the North American F-86 Sabre had been placed to fill the gaps in the country's air defenses, while new British-built swept-wing fighters were being designed. Like the Sabre, they would be capable of even greater transonic performance. At the same time, Britain's first jet bomber, the Canberra, began its flight testing. The Canberra was built by the English Electric Company, under the leadership of Chief Engineer E.W. Teddy Petter. The Canberra had been specified as a replacement for the Mosquito. However, it became clear during the design process that this aircraft would have superior performance to all of the RAF's current fighters. It was capable of flying at 55,000 feet, at almost 600 miles per hour, well beyond the range of any interceptors. Whitehall was not convinced.
In the fullness of time came the summer exercises, whereby traditionally Bomber Command would set up attacking forces coming in from the Low Countries to be intercepted by the fighter defences of this country. And it became very, very apparent that when the Canberras came in, that the Meteors weren't going to get anywhere near them. And progressively, the Canberra force was ordered to come lower and lower and lower until the Meteors could actually catch them. And they actually had to come down to about 30,000 feet before they could do that.
By 1948, the company had achieved a turnaround of opinion in Whitehall, and the go-ahead was given for a design study for a fully supersonic fighter, the P-1.
In the discussions in 1948 about the future fighter, I was asked as a chief test pilot what I felt about the practicability of flying at supersonic speeds on intercepts and in combat. And I said I didn't think there'd be any problem because it was all a question of relative speeds, and that the only thing we had to resolve was controllability, and we had to had to overcome the problems of compressibility and make the aeroplane fly as accurately, as smoothly and precisely at supersonic speeds as the current generations were at subsonic speeds.
The P-1 evolved over a period between 1949 and 1953 against a background of hazardous research into supersonic flight. De Havilland had developed an unusual tailless design, which later became known as the Swallow. The death of Geoffrey de Havilland whilst testing the Swallow led to this project being cancelled. But not before John Derry became the first pilot to fly a British plane through the sound barrier, albeit in a barely controllable dive. At the same time, Supermarine had developed its 510 prototype into the Swift. Although Swifts entered operational service with the RAF, they only ever received lukewarm support. Finally, Hawker had developed its P-1052 into the Hunter. This aircraft had become the best of the series, with the ability to maintain a speed just below the speed of sound in level flight. By 1954, Hunters were replacing the North American Sabres as the RAF's frontline interceptor. Whilst these aircraft could, on occasions, pierce the sound barrier in a dive, it had become clear that this era of fighters with relatively thick wings swept at 45 degrees and high tailplanes would not produce a truly supersonic fighter.
I think the period from 1945 to the end of the 40s was a period when the Air Force was putting up with the new jet aeroplanes, because they're jet aeroplanes, and everybody needed that sort of speed, and so these airplanes had actually outpaced the fastest piston engine fighters. Having said that, I think we would have been badly placed if a war had occurred at that time, because I don't think they would have been found to be very effective. From the 50s onwards, the Hunters came into service, which was a very, very fine subsonic fighter. The Americans had the Sabre, which was a very fine subsonic fighter, and the British started to have the Canberra, which was the world's best twin-engine jet bomber. So it all changed pattern from difficulties and mediocrity in the late 40s to getting to grips with the world's best aeroplanes by the 50s.
Petter and his team set about designing the aircraft known as the P-1, using all the experience from wartime Germany and post-war America. Firstly, the P-1 had a slim, low-drag fuselage with a nose air intake and ducts passing below the cockpit. Two Armstrong Siddeley Sapphire axial flow engines, each capable of producing 7,000 pounds of thrust, were mounted in the central fuselage, one above the other. However, in order to avoid too much engine weight aft, the lower engine was located well forward of the upper. This layout meant that the P-1 had twice the thrust of a single engine with only around 1.5 times the frontal area. Unlike any aircraft flying at the time, it had a radical shoulder-mounted wing, swept to 60 degrees. These wings were incredibly thin, but immensely strong. Finally, the configuration was completed with a thin, all-moving tailplane mounted at the bottom of the rear fuselage. The RAE favored a high position, as it was assumed that this provided more positive control at higher and medium speeds. In order to test this and other ideas, further specifications were issued. The first was issued to Shorts, resulting in the SB-5.
Well, it was a curious, interesting thing to fly. I mean, it was very, very underpowered. From takeoff, which was extremely lengthy, you flew it at full throttle until it was time to go home, because it wasn't going anywhere at all. It was very valuable in assessing. Well, I say it was valuable. It was effective in proving what the English electric theory. The SB5 showed conclusively that the high tail plane with the 60-degree swept wing was a dangerous configuration from a stability point of view, and that tailplane had to be low. From our point of view, it provided a valuable little piece of development, because it was known that with these sort of sweep angles, the leading edge vortex at high angles of attack could adversely affect lateral control. As the vortex flowed over the wing, over the aileron, you could have variations in aileron effectiveness. The RAE had already identified this and were recommending to Wharton that we should have big wing fences on the P1, like the Hunter. Our aerodynamicist said, no thank you, fences are a drag, we don't want to have that. We will create a pressure fence by cutting small cord-wise slots on the leading edge of the wing in areas which were needed for inward vent valves for the fuel tanks. They put the intakes to the vent valves at the back end of these slots, and the slots in fact effectively transferred airflow up over the wing, controlling the vortex as you got to a high angle of attack. We tested this on the SB5. It worked like a charm. We could go from the variations in aileron effectiveness without them at high angles of attack to no variations at all with these chordwise slots. So we cut those slots in the P1 for the first flight, and they remained on the Lightning for the whole of its life. It was a good little program.
A second specification was awarded to Fairey and called for an even more radical aircraft, which would explore the possibilities of a delta wing in supersonic flight. Christened the FD2 following Fairey's earlier experiments with this layout, the aircraft proved to be very temperamental to fly at subsonic speeds. However, the aircraft went on to set the absolute world airspeed record of 1,132 miles per hour in 1956. It was then passed over to the Bristol Aircraft Company, where it was used as a test bed for ideas that were being developed for a new supersonic transport aircraft, Concorde. Through all of this, English Electric quietly got on with developing the P1, and on the 4th of August 1954, Chief Test Pilot Roland Beaumont finally took off for a full flight.
We'd done a week of taxiing to test the brakes, test the steering, more importantly to test the drag chute, the braking parachute. And then when we'd finally got all those things working together, I'd said to the team that we were working with, okay, I think we should do a straight, which is short for a straight hop. We were doing it on Boscombe Down deliberately because it was a long runway. I said, it feels fine to me. We've tested it to nose wheel lift. I'd like to do a straight before we commit ourselves to flying, and let's do that next time. So we then went out and did a full power run-up, accelerate to nose wheel lift, which we'd established previously, held it in nose wheel lift till it accelerated another 10 knots, felt it break ground, eased the stick forward, held it parallel at probably 5 to 10 feet for 500 yards, and then eased it down. And then, so we then established that it broke ground comfortably, it was stable in flight, and more importantly, we were doing the first landing before we did the first flight. And that all is a great confidence builder, and so you knew how it was going to land. So on flight 1, I'd virtually been there before, so that I was looking forward to flight 1 with great anticipation. And it all went according to plan in every technical way you could think of.
Then, on only its third flight on August the 11th, Beaumont took the P1 past Mach 1. Britain now had a supersonic aircraft.
So next flight was Flight 3, and we planned it on the third flight as a normal professional plan to take it up to 40,000 feet, accelerate to 450 knots and see what happened on the Mach meter and how it behaved in control and stability. And somewhere around about Selseybill, going up the channel on a bright sunny day, the Mach meter went to a 9.8 as it had before, hesitated there for a very short time, then swung up to 1.02, and we were supersonic. And I took my hands off the stick, my feet off the rudder bar. The airplane stayed absolutely firm, no trim displacements or anything like that. Small control inputs, left stick, right stick, pitch up and down, smooth, stable responses, and we had a supersonic airplane. No vibration, no buffet, nothing at all. That was a good feeling.
Yet world events were forcing the pace of change. The Soviets had detonated their first nuclear bomb, and were now building a fleet of bombers to carry these lethal weapons. In addition, they had now developed their first supersonic fighter, the MiG-21. The Americans had developed the Sabre into the supersonic F-100 Super Sabre, and had also embarked on a program of developing a new concept in which the aircraft formed part of a total package combining supersonic performance with missile weapons. The RAF was intent on following. At the same time, Britain was developing a long-range jet-powered bomber force capable of delivering nuclear bombs. It was envisaged in a white paper delivered in 1957 that these V bombers would form Britain's deterrent force. At the same time, the defense of their bases, and indeed the whole of the United Kingdom, would ultimately be entrusted to surface-to-air missiles. In the meantime, air defense lay with the all-weather Javelin and eventually the Lightning.
Its limitations were that it was a short-range interceptor, again by, in my view, a very erroneous specification in the early days when we were told that this airplane had to be designed round a radius of action of 150 nautical miles from the V-bomber bases, as its main task was to be only to defend those bases. This limited the airplane enormously, and I actually went, after the first flight of the Lightning, I wrote a very positive handling report on it, and I concluded by saying, however, despite all that's gone before, we will never stand a chance of exporting this Lightning anywhere around the world until we double the internal fuel capacity.
Beaumont got his way, and a ventral fairing was introduced to accommodate an extra 250 gallons of fuel. In addition, the engines had been uprated to Avon 201s, which could provide over 14,000 pounds of thrust each, as well as having four-stage afterburning. It was these mighty engines that gave the Lightning its awesome power. They were so powerful, the pilot could literally stand the aircraft on its tail and climb vertically. A spectacle that would thrill millions of spectators around the world in years to come.
I think it's summarized by the famous pilot of Johnny Howe Squadron 74, when he was interviewed after his first flight in a Lightning, and the interviewer said, well, how did you get on your first trip with the Lightning? He said, super. I was with it all the way till I let the brakes off.
I remember I was talking to, I think it was Rowley Beaumont or Jimmy Dow, and it was at the time when they were trying to sell the aeroplane in Europe, and a test pilot from one of the European countries came over to fly a Lightning from Wharton, and they said to him, we use ordinary full power on takeoff, not reheat. Don't use reheat. And they watched him take off, and he decided he was going to use reheat. He didn't get his wheels up until he was at 28,000 feet, because it ran away with him.
This, the P-1B, was essentially the aircraft that went into production in October 1958, designated the Lightning F Mark I. By now, the aircraft was equipped with twin Aden guns. Also, because it was assumed that the only role for the Lightning was to shoot down attacking bombers, 2 new Firestreak air-to-air missiles were mounted on pylons low on either side of the nose. Finally, Ferranti developed a Doppler radar system in a conical center body, which was located in the circular nose intake. The Lightning could now take its place as part of a weapons system, a new idea from the United States, in which the weapon-carrying fighter was the armed element of a defense system embracing long-range radar, interceptor control, and short-range, last resort, surface-to-air missiles. Later in 1958, Beaumont underlined the aircraft's potential still further by flying at Mach 2, twice the speed of sound.
And when we got up to around about 98%, we knew we were just about to get to Mach 2, and that was a jolly interesting occasion because it was a target, and it was also fascinating to see that the airplane was behaving just as it had been, even subsonic. It was quiet, it was smooth, it was responsive. You're looking for any errors or discrepancies. Engine instruments were fine, the temperatures were in limits. And then we got to Mach 2, and it could almost be an anticlimax because there was Mach 2 on the gauge and nothing else was happening. But then there were tests to perform, again, which could be interesting because you had to establish whether the airplane was still stable directionally, where it might be starting to get difficult. That was positive. Then we were running out of fuel, haul the power back, turn it back to base, and we were descending on this lovely clear day by this time over the Lake District, having gone right round through around Dumfries and right round to Windermere in this supersonic turn. We were then subsonic and coming home with Britain's first Mark II airplane. So it was a good flight.
The first squadron to receive the Mark I in June 1960 was number 74, Tiger Squadron at Coltishall, under the command of Squadron Leader John Howe.
To go from subsonic to an aeroplane that was capable of Mach 2 in level flight was quite a jump. Quite a jump. And of course the introduction of a weapon system that was so more complex and effective than we'd had in the past was a big jump.
The intention was to gain experience in integrating a supersonic interceptor into Fighter Command's key eastern sector defense structure. The task was enormous, particularly on the ground crews, who had to keep these complex new fighters serviceable.
All new aeroplanes have teething problems, and the Lightning was no exception. As I recall, the main problem with us was electrical, one way or another. And the supply system hadn't yet caught up with this change. I mean, the introduction of a new airplane, new system, new parts, and everything was new, and consequently, with the airplane having these electronics go wrong so often, the supply wasn't keeping up. So we got a tremendous amount of help from English Electric on this, and I would ring Rowley Beaumont or Jimmy Dow and say what had gone wrong and the part I needed, and they would say, well, yeah, come and fetch one. So we'd send a Meteor or the Hunter 7, fetch the part, get the Lightning back in the air, and we carried on like that.
Additional pressure arose from the need to display the aircraft in order to stimulate potential foreign sales. 74 were ordered to have a 4-ship display team ready to fly every day at the Farnborough Air Show in September of that year. It was a tough order, because they still didn't have 4 serviceable aircraft, at least not at the same time.
From the point of view that we couldn't get on with our operational training as we wished, but it was fun and we enjoyed it. Getting 9 airplanes in the air and having 12, the whole lot serviceable to choose from, was quite a feat on the part of the ground crew. But I worked out that to train a formation aerobatic team of 9, I only needed 3 aeroplanes, because nobody has more than one between him and the leader. So if they could give us 3 to train for formation aerobatics, I could work up the team, and the other aeroplanes would provide the operational training for the conversion.
Now the RAF shows off the Lightning, its first supersonic
Come
fighter.
September, 74 was there, ready to impress the crowds at Farnborough. Their display established the Lightning as a firm favourite on the airshow circuit throughout the aircraft's service life. Apart from their display commitments, 74 Squadron were having to perform their role as a front-line squadron in Britain's defence. Pilots had to learn to fly the Lightning whilst maintaining an operational capability. It was a tough requirement.
And the conversion was fairly straightforward. We didn't have 2-seaters in those days, and you were taught about the systems during lectures and things like that. And then you had 10 hours on the Lightning simulator, which was a reproduction of the Lightning cockpit. So by the time you got into the air, you knew what to expect from all the instruments. And towards the end, or on your last sortie in the simulator, basically you had to try and get the aeroplane into the air, because they kept giving you emergencies on the ground. And when you got into the air, you then had to try and get it back. So by the time you'd finished the simulator side of things, you really felt you could handle those sort of things. Then when you came to fly the aeroplane, that was a totally different experience. I mean, the power was just unbelievable.
To make matters even more difficult, the squadron was now taking what were termed first tourists. These were pilots who had never been with an operational squadron before, and who were now having to make the jump from flying subsonic jets, such as the Hunter, to Lightnings with Mark II on tap. The first flight in a Lightning was an experience a pilot never forgot.
Taxiing out, we had a system where you had to keep the electrics online. One of the engines had to be at a certain revs, only about 50%, something like that. And if you didn't use the brakes, you'd be building up to about 70 knots. In line up with the runway, and you could just feel this power. On the brakes, open up the engines and let go, and it was just away. And I remember trying to get the nose high enough to reduce the speed to 450 knots, which was the climbing speed. At about 20,000 feet, I went supersonic. And I think a lot of people did on the first solo. But it handled beautifully. It was a super airplane to fly.
When you took off from Courteshaw, you had a very rapid rate of climb, and in the radar center there would be a light come up to warn them that an aircraft was taking off from Courteshaw on a climb. I decided one day to do a timed climb to 30,000 feet. And so I put reheat in and let the brakes go and set the stopwatch going. And I was passing 12,000 feet when air traffic called me and said, check at 15, friction ahead. I immediately replied, sorry, now passing 18. And we got to 30,000 feet in 1.5 minutes in reheat.
But it was a great aircraft to fly, a great, the last of the great sports cars, many people will tell you. It was built to fly with delightful handling characteristics. But once you were airborne, it was actually very busy, because you had to fly the thing and at the same time operate this the radar and weapon system.
I really couldn't believe I was so lucky to be flying this airplane. It was a quantum leap, of course, from the Hunters that I'd been flying. Certainly, I didn't find it as difficult to fly as I perhaps imagined, in the sense that it was a fairly easy airplane to fly.
lightning's Achilles heel, its lack of endurance, was a constant concern, and the aircraft would have proved totally inadequate had it been necessary to reinforce RAF commands overseas. However, the technique of in-flight refueling had been perfected, aided by an availability of Valiant and Victor bombers converted to do the job. Converting the Lightnings in order to take advantage of this capability was fraught with difficulties. Firstly, there was the question of where to put the probe.
When we first saw the probe mocked up in the mock-up at Wharton for the Lightning, probe or the Lightning, I couldn't believe what I was seeing. This was one of the few occasions when there hadn't been direct coordination between the design department and the flight department, where normally all flying matters there was sort of interchange of views. And the probe, I looked at this thing from the cockpit of the mock-up, and the probe head was behind my shoulder. And I thought, how the hell am I going to steer that into a drogue that's coming down like that? And I pointed this out to the designers. They said, oh, well, nobody's objected before. So I said, well, I'm objecting now. They said, too late, we've already issued the drawings. So I said, well, you're going to have to change the drawings, aren't you? And we had a hell of a row about that, and eventually got it extended forward so that you could see the probe head in the windscreen where it ought to be.
Refueling initially, it was tricky. I don't know whether you've seen the refueling probe on a Lightning, which was very much an afterthought, and like many other things. But it was relatively tricky initially, but rather like riding a bicycle. Once you've got the act, it becomes fairly second nature. And certainly if you do a lot of it, when you're doing it sort of on a regular basis, then the problem tends to go away. The problems with the original flight refueling of the Lightning was that we were refueling against the Valiant tanker first of all, and then the Vulcan, which had only at that stage a centerline probe and drogue. Sorry, not a centerline probe, a centerline drogue with a big basket, which of course was effectively designed to refuel other V-bombers. So you had this enormous basket into which you stuck your little Lightning probe, and if there was anything of a wiggle on this hose, it would just literally whip the end off your probe, and that was it.
Progressive development continued, resulting in the Mark II in July 1962, with fully variable afterburning avens, as well as an autopilot and steerable nose wheel. This was followed by the Mark III. The Lightning F3 marked a major turning point in the Lightning's development. Firstly, it had a broader, more angular fin, flattened at the top. It also had a kinked and cambered wing edge, which was flatter at the end than before. But perhaps even more significantly, the Lightning F3 had no guns. The Firestreak air-to-air missile had been developed so that it was now fully integrated into the aircraft's guidance systems.
Big mistake to drop the guns. I think every fighter pilot would tell you to drop guns from a fighter aeroplane, yes, and certainly we all felt that was a big mistake, and of course it was redressed when the Mark VI came into service and they put them in the pack. But again, it was a problem of space in the aeroplane. If you put a bigger weapon system in, a bigger radar with lot more black boxes, there just isn't room for guns, and that was the problem, I suspect.
Call data, primary 36, secondary 9, mission number 74, scramble, 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 acknowledge.
This was the era of QRA, or Quick Reaction Alert. This meant that aircraft and pilots were kept in a state of readiness, so that should intruders be spotted, the Lightnings could be scrambled to intercept them.
our role was to intercept far enough out over the North Sea, basically high or low level, to prevent them from firing missiles at us. That did not require long range. What we had to be able to do is react quickly, get out there fast, fire, get back, turn around and out, and back and out and back.
The Lightning Force was much better looked after in the sense that we did most of our QRA from crew room readiness initially, and then eventually, of course, they built the QRA sheds where you were very well looked after. The aircraft was covered, catered for. You had sleeping facilities, so it became quite a pleasant environment. In that, if you can call sitting QRA a pleasant environment, because of course, for quite a lot for the time you're on QRA, you're dressed in your flying kit. And when you're wearing an immersion suit, that wearing it for a lengthy period, it becomes fairly exhausting.
We sat QRA, quick reaction alerts, periodically, and the aim there was that from getting the scramble order, whether you were relaxing in the crew room, say, or asleep at night, 10 minutes later you could be airborne, and that could be done. There was no doubt about that. The aircraft, the longest thing was getting into your kit, so you kept your kit on, and then you ran out to the aircraft, pressed a button, the hangar doors opened, front and back, you jumped into the jet, and 2 buttons, and you were started.
74 Squadron was now based up at Lucas, responsible for patrolling the vast areas of the North Sea, particularly the vital gap between Western Scotland and Greenland. In 1966, 74 Squadron replaced its F-3s with the new F-6. Firstly, the pilots got their machine guns back, for the F-6 could carry combinations of armaments in special packs. The new aircraft had a much enlarged ventral pack, which contained a fuel tank holding 610 gallons. There was also an option to carry 2 over-wing tanks, each containing a further 250 gallons. They had to be mounted on top of the wings because there was no room underneath for the tanks and the undercarriage. These refinements, coupled with an enlarged wing, meant that the Lightning's abysmal range was increased by 20%. For 74 Squadron, this was particularly important, for in June 1967, the squadron left for Tenga, Singapore. Operation Hydraulic was the largest in-flight refueling operation to have been carried out by the RAF up to that point. It was an epic journey which began just as the Arab-Israeli War broke out. The leg from Cyprus to Mazara proved to be particularly hazardous, as their route took them over Turkey and Iran.
I flew the same aeroplane all the way from the UK to Singapore, simply because the thing was unserviceable the whole way from UK to Singapore. I think it was my starboard wing, the tanks never fed. The fuel I took had the same fuel when I arrived in Singapore as I left Lucas with. And so the aeroplane was basically unserviceable the whole way, and what I had to do, of course, was to do considerably more flight refuelings, which the tanker force were well able to cope with on the way there, just to get the airplanes out there. And we arrived, again from memory, we arrived on the right day about 30 minutes later than actually planned 6 months before. So I got there with my 3 aeroplanes virtually on day, on time, and that to me was a tribute to the success of the planning, particularly by the tanker force.
Throughout this period, Lightning squadrons continued to display their aircraft around the world. But it was not until 1966 that the sales effort began to show results.
What we had to do was to explain to the Saudi Arabians that if they bought a Lightning with all its enormous capability, it wouldn't be the Lightning that the Air Force was restricted with, which was the Mark VI, but that it would have additional capabilities of reconnaissance, up to supersonic speed reconnaissance, underwing stores, rockets or bombs, 2-inch rockets. It was a multi-role airplane, and overwing tanks as well. We had done all of these things separately. Now we were going to bring them all together, except for the Vinton camera pod, if the Saudis wanted it. They came over and they did an evaluation. They said, we will not entertain thoughts of having your airplane until our test pilot tests it, you see. And they sent a chap over by the name of Captain Hamdan and said, we will fly your Lightning. And we said, okay, fine. What experience has he had? And they said, oh, he's current on Sabres. And I said, yes, well, that's all right. A Sabre pilot could convert onto a Lightning with some dual. There won't be time for that, the Saudi authorities said. He'd do one dual flight and then one solo flight in the Lightning, and during that solo flight in the Lightning he must go to Mark II. So this was a chap who was going to do his first flight on a solo flight on a Lightning and go to Mark II on one flight. I mean, it throws the Lightning conversion unit at Coltishore and things into complete disarray, a thought like that.
The Lightnings exported to Saudi Arabia and Kuwait were variants of the Mark VI, but with ground attack capability, as well as versions of the 2-seater T5. The F-6 was to be the last totally British-built supersonic aircraft, for in 1966 an order had been placed for the McDonnell Douglas F-4 Phantom. Whilst the aircraft's design was already 14 years old, it was well proven in combat in Vietnam. It was while locked in combat with the North Vietnamese MiG-21s that the American pilots learned the value of a machine gun.
Well, for conventional fighter pilots, they couldn't see the point of a fighter without guns, because they felt that it was most likely that you'd come up against other fighters. And because an air-to-air missile in those days required space to align and lock on and all the rest of it, you could be in a situation where you would be firing against other fighters who had guns and you didn't, and you were therefore at a disadvantage. I can see the missile was wonderful for air defense, but not air-to-air combat.
Like the Lightning F-3, was equipped only with air-to-air missiles. The MiG-21 which was in many respects a Russian Lightning, was far more maneuverable and could turn in tight enough to shake off the missile. The defenseless Phantoms made easy targets. The Americans soon learned their lesson, and Phantoms were subsequently fitted with guns. But would the Lightning have made a good dogfighter?
Yes, the Lightning was a very good dogfighter. It had the power. It had the ability to turn very, very sharply. It could accelerate. It really was, I thought, a good dogfighter, yeah.
The Phantoms, however, had a more advanced radar system that enabled the pilot to look down as well as forward. But it now required 2 crewmen to manage all its systems. In order to get the most out of its fighter force, the RAF began to experiment with a new concept, the mixed fighter force. The strategy was for the Phantoms to use their look-down capability to seek out bomber formations or ground targets, while the Lightnings used their look-forward radar to seek out interceptors. As both aircraft had similar performance, the combination worked well, but their days were numbered.
We were complementary. I think each aircraft is complementary to another, and the requirement effectively is to use the force in the best possible way, either by operating them together or in a combined sense if you can. And towards the end of my time at Binbrook, then we got into the mixed fighter force, because at the time they were introducing the Hawk, which was the jet trainer, it had no, if you like, no radar capability at all, so it needed to be led into the fight or led into the bomber stream, although it had a weapons capability. And again, the Air Force was reducing in size, so the numbers of airplanes going down, so the Air Force felt and found that it needed to use every available airplane that it could. So you now get into the area of trying to operate various types of airplanes together, and that's where the mixed fighter force came in. And the original intention was that we would all, Lightnings, Phantoms and Hawks, would effectively all go together towards the bomber, to the cap points, and then, if you like, not do our own thing from there, but then a radar equipped airplane would take a Hawk into the bomber stream. So we would arrive at the point and then go into the bomber stream, and then once you're in the bomber stream, then you're on your own effectively.
The Lightning was only supposed to have a service life of 8 years, and as early as the mid-60s, plans had been put in motion to find a long-term replacement. Given the enormous cost of developing supersonic aircraft, Britain was forced to find partners. The first result was the Jaguar, a joint effort between Britain and France. The Jaguar entered service with 8 squadrons in the early 1970s as a strike fighter. Today, the Jaguar is still serving the RAF as a tactical attack and reconnaissance aircraft. But perhaps the most impressive of these work-sharing schemes was the Panavia Tornado. Although originally planned as a replacement for the Canberra, the design was flexible enough to allow it to be adapted as a missile-armed interceptor fighter. Today, the Tornado F-3 is the mainstay of Britain's aerial home defence. The Lightning, however, soldiered on until 1988, when numbers 5 and 11 squadrons traded in their Lightnings for Tornado F-3s, 40 years after the original requirement had been formulated. The Lightning, which was created at the beginning of the Cold War, had survived to witness its conclusion. Today, the Lightning is remembered for its blistering performance, a performance that even some of the most advanced fighters in the world cannot match. Yet the Lightning set more benchmarks in aircraft design than speed alone.
Highly swept wings, low tailplanes. They've all got them. You have a look round all the jets, the exotic Russians, F-16, F-15, excluding the French, which is another matter, the EF-2000, they all have swept wings, low tailplane. And that is a legacy of the Lightning. The Lightning started the fashion, and that's the way they'll always be. Unless you go to a pure Delta.
I think that we had hoped that we would go through the sound barrier in level flight as opposed to a screaming dive downhill. I mean, the Hunter could go through the sound barrier downhill, and the American similarly in the Sabre, etc., but to go through it in level flight, that is an achievement. And it was certainly at that time. And I think it made every Briton proud, every man that was involved in aviation anyway. Oh no, I think the Lightning is a nice little milestone in our aviation history.
I think the legacy of the Lightning, as far as our Royal Air Force is concerned, is that it did bring technology to the forefront of the people that had to fly it, service it, operate it, control it in the Sector Operations Centre. It was a high-tech beastie for its time, and luckily our very senior officers now, both aircrew and engineers, were brought up with that concept. So I think it's probably made our Air Force much more, or helped to make us technology conscious rather than frightened of technology. That's just my view.
I would have thought that certainly in terms of recognition that you need an airplane with a dogfighting capability or an air combat capability, that's been seen to be a continuing requirement, and we're now into Eurofighter, because with the, if you like, the Phantom and then the Tornado F3, I haven't operated the Tornado F3, know very little about it, but reputedly it doesn't have, it wasn't designed, doesn't have that sort of capability. Also, the need, if you like, for the supersonic dash is still seen to be there, and aerodynamically I'm sure the Lightning contributed to that.